Hi, I'm Dr. Jason Brinkley, and this is The Solid State. By the end of this video, we'll be able to relate the properties of various classes of solids to the structure of solids, and describe the process of melting and sublimation. Now, there are two types of solids. There are crystalline solids and there are amorphous solids. We're going to focus more on crystalline solids, but amorphous solids do not have a regular repeating structure, whereas crystalline solids have a regular repeating pattern to their structure. Things that are amorphous solids are things like rubber or glass or plastic. Okay? Crystalline solids are things like sodium chloride or diamond or ice. These are all crystalline solids. So the types of crystalline solids we're going to talk about are ionic, covalent, molecular, and metallic. Okay? So here we have ionic. This is the sodium chloride lattice. Here we have covalent, which is diamond in a carbon structure. Molecular, we have solid methane. And metallic, we have a piece of metal. Ionic solids have a lattice structure that is made up of the ions. Okay? So you can see it's a regular repeating pattern of ions in this crystal. These are usually hard, they're brittle, they have a very high melting point because to melt these, you're breaking the ionic bond. Some of these are water soluble, some are not. The water solubility has to do with the ability to solvate the ions and whether it's more energetically favorable to have them as solvent-separated ions as opposed to being in the regular repeating structure. They are non-conductive as solids, but conduct as liquids, or if they're soluble, they conduct in the aqueous phase. Covalent solids are held together by covalent bonds. These have very, very high melting points because you're breaking a covalent bond, which is very difficult to do. They are rarely soluble because of the covalent bond, and they are non-conductive. Okay? Doesn't matter if you can liquefy them, they're still going to be non-conductive because there are no ions present like there are in ionic solids. Molecular solids are covalent compounds that are held together by intermolecular forces. These are frequently soft, have low melting points, often are volatile, and they are poor conductors. So here we have water in its crystalline structure in ice. You can see that there is a regular repeating pattern of a six-membered ring, and I started drawing on the wrong ring. Let's see if I can pick out the right ring. 1, 2, 3, 4, 5, 6. Well, I think there's something a little strange to this picture. I can't pick out the right 1, 2, 4, 5, 6. There we go. That one's the right number. So we have actually a hexagon pattern inside ice. It's that hexagon that actually allows ice to have such amazing properties like expansion when it's freezing. It's relatively soft, believe it or not. Ice is relatively soft, and it has a fairly low melting point of 0 degrees C. Ice is also a little bit volatile. It will evaporate on its own to go to the gas phase. Metallic solids. Metallic solids are modeled by what we call the sea of electron model. In other words, we have these positive spheres of the nuclei in this just sea of electrons, just electrons flowing all over the place. This explains the properties of metals, that they're shiny, They're good conductors of heat and electricity, and they're malleable and ductile. Malleable means they deform on being struck, and ductile means they can make wires. You can pull them apart. So all of these things are possible because the nuclei are kind of sitting in this mush of electrons, this sea of electrons, which is why you can hit them and they deform, and why you can pull them into wires, and why they're shiny and why they're good conductors. Finally, we have two processes that are slightly related but different. Melting is the conversion of a solid to a liquid phase. Okay? What happens during melting is that the kinetic energy of the particles starts to increase. They're just sitting there sort of shaking in place in terms of being in the solid phase. And when you start to heat it up, this shaking gets faster and faster and faster until finally you break apart and you get the ability to flow, going to the liquid phase. Now, the other process we have is sublimation. Now, sublimation is the conversion of a solid to the gas phase without going through the liquid phase. Okay? So what happens is, as these things get kinetic energy, they break apart and they fly off as a gas instead of as a liquid. Things that do this are things like dry ice, which is what we have here, mothballs or iodine, okay? And things that are going to sublime are going to have a sufficiently high vapor pressure so that this happens naturally. In the north here, we've seen this occur naturally in winter when ice goes from a solid ice phase in terms of snow directly to fog, which is ice as a gas. So sublimation is a very neat process, and not very many things do it, but there are sufficiently enough things to do it that we should talk about this as a process. I hope you've enjoyed this video, and I look forward to seeing you in the next.